Good morning, scholars. Today we're going to be going over the quadratic formula. Probably the most important thing that we're going to learn all year. It's like when you need to, use a specific tool, always go to quadratic formula first. It's amazing. So the first thing that we're going to take a look at is the use, so how to use it and what the actual formula looks like. Then we're going to go into just a piece of the quadratic formula called the discriminant, which we saw in our overview a couple lessons ago. And this discriminant will tell us how many solutions that we're going to get so that, we can calculate pretty easily if we need to go forward using the whole formula or not. And then the last piece is we'll actually see how the quadratic formula connects to completing the square and where it actually comes from. All right, well, let's get started. So our first problem is to find, solve for x. So we're going to try to take this equation and we're going to solve it for x. And to do this, we're going to use a quadratic formula. So what is a quadratic formula, you say? Well, it's actually a formula that gives you what x has to be. So x in this case is equal to negative b plus or minus the square root of b squared minus 4 times a times c. All that's still under the square root. And then everything is divided by 2a. So to do this, you need to remember how to find the a, b, and c from general form. So a is the coefficient of the x squared term. So a in this case is 2. B is the coefficient of x. So b in this case is equal to 5. And c is the constant term, which we can see right here. So c in this case is going to be equal to 3. So now if we plug all those numbers into the quadratic formula, we get out our answer. So x in this case, oh, that's a highlighter. There we go. X in this case is going to be negative 5 plus or minus square root 5 squared minus 4 times 2 times 3, all divided by 2 times a, which is 2. So that's negative 5 plus or minus the square root. 5 times 5 is 25. 4 times 2 is 8. 8 times 3 is 24. 2 times 2 is 4, giving us a 4 in the denominator. So I'm going to need to move down a little bit here, maybe scrunch this in, move it up. All right, so then we should be able to simplify that. So that's going to be equal to negative 5 plus or minus the square root of 1 over 4, which is equal to negative 5 plus or minus square root of 1 is just 1 over 4. So that gives you two answers. So x could be equal to the plus sign, so negative 5 plus 1 over 4, which is negative 4 over 4, which is negative 1. That's our first answer. Or x can be equal to negative 5 minus 1 over 4, which is negative 6 over 4, which is negative 3 halves. And that's it. There are our two solutions. So the second thing we wanted to talk about is the discriminant. So it's this piece of the quadratic formula that is just underneath the square root sign. It's this b squared minus 4ac. And why this is important is because if that number is actually greater than 0, like in our last example, then you actually get two solutions, or x-intercepts, because you get a positive number here and you can add or subtract it. If it's actually equal to 0, then that means that you only get one solution. So your parabola, the vertex, is actually on the x-axis. And then the last case is if this number is actually negative, so if it's less than 0. So if this b squared minus 4ac is this number right here, if that's less than 0, then you're taking a square root of a negative number right here in the quadratic formula. Well, you can't do that. So you actually don't get any solutions there. And what this corresponds to in terms of the quadratic would be the quadratic function actually sits either all above the x-axis or all below the x-axis. So it never actually connects or makes any roots or zeros. So it's highly useful in some applications and can be a quick check because you just have to figure out what b squared minus 4ac is and you know the number of solutions. You don't have to find the full quadratic formula. So this last piece is the connection to the other technique that we've seen called completing the square that works for anything. So the origin of the quadratic formula actually starts out with an equation in standard form. So all of the stuff is on the left-hand side. We're equal to 0, so we can use the 0 property. And then we're just going to complete the square. And unfortunately, we're going to be using all letters so that we'll see what we get. So first step, we said we wanted to make things easy, so we're going to divide everything by a. If you do that, you get x squared plus b over a times x plus c over a is equal to 0, since 0 divided by anything is just 0. So then you can make your square. Put the x squared in the upper left. You split your b over 2a evenly. So that means that you're going to get a b over 2a here and a b over 2a in the lower left. And so then when you're completing the square, you actually have to add that number. So you factor everything out. You factor out the x's. You get a b over 2a here. Still a square because these sides are equal. You multiply b over 2a times b over 2a. That gives you the number that you're going to use to complete the square. So b times b is b squared. 2 times 2 is 4. And a times a is a squared. So since we're adding that, we have to subtract it. Alrighty, so gonna scrunch this down a bit so we have some more space to work. So then we can see what this leaves us. So the red part is going to become the x plus b over 2a squared. We're going to add everything else to the other side. So then we got minus our blue piece. Plus our c over a equals 0. Now we're going to get everything to the other side and take the square root. So we're going to add b squared over 4a squared. Going to subtract c over a. So we get x plus b over 2a squared is equal to b squared over 4a squared minus c over a. Scrunch it up again and put it over to the other side. Maybe draw a line this time so we can work on the other half of the page. All right, so then we need a common denominator so that we can actually add these two things together. So we're going to multiply the c over a times 4a. Top and bottom. So, gives our x plus b over 2a squared is equal to. Now we're starting to see some stuff. So b squared minus and then 4ac. That should look familiar. That's the discriminant sitting on the top there. And then our common denominator is 4a squared. Now we're going to take the square root of both sides. When we do that, we get just an x plus b over 2a on the left, and that is equal to square root of b squared minus 4ac. That looks very familiar. Divided by, and then the square root of 4 is 2. And the square root of a squared is a. And we're just going to add in our plus and minus because we took a square root. So then we can subtract b over 2a from both sides. And we get x is equal to negative b over 2a plus or minus square root b squared minus 2 or 4ac over 2a. Don't need to get a common denominator because they have a common denominator. And what do you know? Quadratic formula pops out. Isn't that neat? And you get this nice, happy little formula. It is so beautiful. One of the best results on all of algebra. All right, well, have a blessed day.